Hello, my dear learners. How are you all? I hope everybody are doing great. Welcome to Kulkarni classes. This is my second video. In the first video, I have discussed your study tips and mistakes to avoid if you are in class 10th. Please, I'll give the link at the end of this video. Go and watch that video. Okay, in today's video, we'll start with the science chapter 1, chemical reactions and equations. Very interesting chapter, important also. So let's start without wasting any time. I'll make two videos, one part 1 and part 2. In part 1, today's video will discuss all these concepts: physical change and chemical change, chemical reaction and its characteristics, what do you mean by chemical equation, how to write chemical equation, and few important chemical reactions in activity they are mentioned in your NCERT textbook, that we'll discuss, and then balancing of chemical equation step by step. Okay, and the remaining concepts like types of reactions, corrosion, rancidity, we'll cover them in part 2. Okay, what do you observe in all these pictures? You see pictures, right? So there's melting of ice, burning of a candle, here fruit is ripened, here there's a formation of rust on iron, paper burnt into ash, cooking. You see some more examples like milk is turned into curd, right? Respiration process, digestion of food. You see plants growing. So now you may ask, what is so new about these examples, ma'am? We see them every day, right? You see all these examples every day. We witness them every single day, right? But do you see there's something common in all these examples? They all undergo some change, some transition is happening, some transformation is happening. What is that? Here ice is converting into water. Here the raw banana is converting into ripe one. Right? Here paper is converting into ash. You see change, right? So to understand these, the day-to-day changes, so every substance undergoes change. Okay, to understand this change better, in science we have classified these changes into two main types, that is your physical and chemical change. I hope you have studied in your previous classes what is physical change and what is chemical change. Once we'll revise what is physical and chemical changes here. So there's one more point in these changes. Some changes are desirable changes, some are non-desirable. Some changes are very quick, like for example this paper burnt into ash. It takes few minutes or takes very few seconds, right, to burn it into ash. This change is very fast. Some changes are very slow, like growing of a plants may take days, months, or some years to grow into a big tree. And some desirable changes and undesirable changes means there's this milk turning into curd, right? It's a desirable change. We want that change. Some undesirable means here the rusting of iron or decaying of food, right? And some changes are periodic and non-periodic also. What do you mean by that? Some changes are periodic means there's a change like natural changes, day and night. There are change in seasons, right? There's so many changes. So to understand them better, as I told you, we'll have to see what is physical change and chemical change. Physical change, it is a change in its physical properties like size, shape, color and state. And this physical change is a temporary change and no new substance formed. And the chemical composition of the original substance remains the same. Whereas chemical change is a permanent change and a new substance is formed with chemical properties are different. The chemical properties are different from that of the original substance. So what does that mean? So there is a physical change means there is a change in its only physical properties like size, shape, okay, color and state of matter. And the physical change is a temporary change and no new substance formed. If at all the change is a chemical change, then the change is permanent and a new substance is formed with new chemical properties. Okay, now let us understand physical change with an example. The example for physical change is your melting of ice. Okay, now take ice at room temperature. Ice is going to melt into water, right? We all know. And water at 100 degrees Celsius, if you boil it, it is going to convert it into, it becomes water vapor. So what do you see the change? The change is in its state, right? There's change in its state of matter. Here ice is solid in nature. When it converts into water, it becomes liquid, and water undergoes change to become water vapor. That is gaseous in state, right? There's only change in state of matter. There's no new substance formed, right? There's no new substance formed. Water molecular formula is H2O, the chemical composition, and even in its solid state it is H2O, ice formula is H2O, and even in its gaseous form it is H2O. There is no new substance formed, and the change is temporary. Okay? Because ice gets melted into water, again on water freezing it becomes ice, and water on boiling becomes water vapor, and water vapor again on condensation gets converted back into water. So there is only change in its state, and there is no new substance formed, and the change is temporary, right? You can reverse the reaction. So that is the physical change. So now let us see the examples for chemical change. One example is your rusting of iron, right? Where iron, so especially in this rainy season, when you keep this iron at in the open air with moisture, you're going to get, there's a formation of rust. There's a brown layer formed, right? And there's a release of hydrogen gas. So the iron properties are so different from that of the rust. The rust is the new substance formed. Okay, the new substance is formed, and this is a permanent change. So hence it is a chemical change where the new substance iron is transformed, changed into a new substance, that is your rust. Okay, and the second example is your formation of a curd, where milk, you are going to take milk and add a little curd. You are maintaining certain temperature, right? You see you take warm milk, add little curd, and then it gets converted into curd. The properties of milk and curd are so different, right? The texture, taste, and smell of the curd is different from that of the milk. It has a very new properties compared to milk, and it is the new substance formed, and the change is permanent. You cannot, get back milk from curd, right? So this is the chemical change. So whenever you see any example, just look for any new substance formed. Yes, iron is converted into rust. This is a new substance formed, and the properties of rust and iron are different. The new chemical properties are seen. And in the formation of curd also, the new substance formed is curd, and the properties of curd, texture, smell, taste, everything is different from that of the milk. So here also there is a new substance formed, and the change is permanent. Hence these are the examples for chemical change. Now you can easily identify whether it's a physical change or a chemical change, right? Physical change is a temporary change. If at all there is only changes in its physical state like color, shape, and state of matter in appearance, then you can say that is a physical change. Or if there at all there is any permanent change, there's a formation of new substance with new chemical properties, then you can say that it is a chemical change. So let's move on. Let's see the difference between these two ones. Let us see the difference between physical change and chemical change. So here it is, there's no new substance formed in physical change, and chemical change, new substance formed with entirely different properties. We have seen with example. In physical change, the change is temporary. In chemical change, the change is permanent. Here in physical change, the change can mostly be reversed by simple physical methods, but chemical change, the change cannot be reversed. But here in physical change, we have seen it is reversible. With example, melting of ice, ice melts into water, water again on freezing becomes ice. But in example like chopping of vegetables, take for example some carrot or tomatoes, when you chop them into small cubes, the shape and size of the substance is changed, the physical property is changed, but we cannot get back the whole vegetable, right? Once it is chopped, it cannot be reversed. So sometimes it is irreversible, but mostly you can reverse the changes with simple physical methods. But in chemical change, the change can never be reversed. It is irreversible. Examples for physical change: melting of ice, formation of clouds, crystallization of sugar. In chemical change, we see cooking of food, formation of curd from milk, rusting of iron, digestion of food. There's respiration. How do you see that in respiration? We inhale oxygen, right? There is some chemical change that is happening within the body, and we are going to emit carbon dioxide. So oxygen is inhaled, and we are exhaling carbon dioxide, CO2, and the properties of both are totally different. CO2 is a new substance which is formed with totally different properties. So I hope now the difference between physical and chemical change is clear. Let us move on. Now we'll see what is chemical reaction. What is chemical reaction? The process through which a chemical change takes place and the reactants converts into product. That is called your chemical reaction. We have seen milk getting converted into curd, right? That is an example for chemical change. Now the process through which that milk is getting converted into curd, there is something happening, right, in between. So that process is called your chemical reaction, where the reactants converts into products. Okay, so the substance that react with one another, they're called your reactants, and the new substance thus formed is your product, right? Say for example, H2 gas reacting with oxygen gas will give you H2O, right? So here the H2 and O2 gases are your reactants, and the substance formed water molecule is your product. Okay, here there is some process through which this oxygen and hydrogen combine to form water molecule, and the process is called your chemical reaction, and the reactant is getting converted into product. Okay, now let us move on to characteristics of chemical reaction. Okay, now I've said that if there is any chemical change, definitely there is some chemical reaction taking place, right? That is the process through which the chemical change happened. Definitely there is some chemical reaction. But how do you trust that, right? You need some visible evidence to say that, okay, there is some chemical reaction occurring here, right? So that is the reason why we need to study these characteristics of chemical reaction, through which you can understand that that chemical reaction is occurring. Okay, so the characteristics of a chemical reaction: the first is change in state. If at all there is any change in state, like solid getting converted into liquid, liquid to gas, right? So if there is any change in state, it is an evidence that some chemical reaction might have occurred. Okay, for example, everybody gets confused with the example is classic example for which depicts both physical and chemical change. So take a candle. When you light the candle up, you see two changes, right? One is melting of wax, another one is burning vapor. So this melting of wax, where the wax melts into liquid and then it becomes again solid after cooling, this is your physical change, where there is no new substance formed, only there's a change in its physical state. But burning of vapor, it gives out carbon dioxide, there's a new substance formed, hence it is your chemical change. Okay, don't confuse this example with the change in state for chemical reaction. Okay, so this is a reaction where both chemical and physical changes are taking place. Here physical change is taking place, where this change in state of wax is melting and again it is getting solidified. It's a physical change here. But here what are we talking? There's a characteristics of chemical reaction. Chemical reaction where it occurs only when there's a chemical change. Okay, take for example hydrogen. Okay, when it is reacting with oxygen, you are going to get H2O. Okay, so hydrogen gas, oxygen is also gas. When they react, there's a formation of water which is liquid. So here now you know that there's a formation of new substance. Okay, That is why it is a chemical change, and there's a change in state from gas to liquid, which shows that this is a chemical reaction happened. Okay, so this is an example for change in state. Let us move on to the next, change in color, right? What is that change in color? Take iron and just dip it in a copper sulfate solution. What do you get? There's a formation of iron sulfate plus copper is deposited on the iron. So this copper sulfate solution is blue in color. This is a blue solution. Okay, this is a solid. Iron nail is a solid. Here there's a blue solution, and the iron solution, iron sulfate that is formed is green in color. Okay, there's a change in color. So this is an example for change in color. If at all in any reaction there's a change in color, means there might have happened some chemical reaction. Okay, this is the second characteristics. Now let's move on to the third characteristic, that is your evolution of gas. Right, there are some reactions when the reaction happens, so evolution of gas takes place. For example, let's take any metal Zn. When it is reacting with H2SO4, which is an acid, right? This is a metal, this is an acid. You're going to get ZnSO4, which is zinc sulfate, and there's a formation of hydrogen gas. So this is a gas which is released. So any metal, when it is reacting with acid, you're going to get some evolution of gas is happening, means there's some chemical reaction might have taken place. Okay, and the fourth characteristics is change in temperature. Very important. When some chemical reaction takes place, there is a heat is produced or heat is absorbed. So whether the heat is absorbed or released, whether the beaker becomes heat or cold, you can say that chemical reaction might have taken place. Based on that, the heat absorbed or heat is produced, we classify them into two different reactions. One is exothermic reaction, another one is your endothermic reaction. What do you mean by that? Let's see. Change in temperature. Let us see. There's, if at all there is any change in temperature, right? Change in temperature, we see one is exothermic reaction, another one is your endothermic reaction. What is this exothermic reaction? The exothermic reaction, heat is produced. Here heat is absorbed. Best example here is your neutralization reaction. Okay. What happens in neutralization reaction? We take acid, we take base. In the reaction, you get salt plus water plus heat is released. Okay. So you'll perform this experiment once you reach 11th standard, where you take acid-base reactions, titrations you are going to perform, where in the neutralization reaction, acid-base reaction, there's a formation of heat. When the two acid and base you start adding up, the beaker gets heated, right? You can actually feel the heat when you touch the beaker. So there's a heat formation, there's heat exerted there. So that is heat. When the heat is produced, it means the exothermic reaction. If the heat is absorbed, in some cases what happens in some reactions, the heat from the surroundings, it is going to absorb and use it in the chemical reaction. So that reaction is your endothermic reaction, and if at all the reaction is taking place in a beaker, you can feel the beaker is getting very cold because it is absorbing heat from surrounding and using it in the reaction. So the beaker becomes cool here. Here the beaker becomes very hot in exothermic reaction because the heat is released into the surroundings and you can feel the warmth. Example, the neutralization reaction. And one more example is your respiration. Okay. Here, best example is your photosynthesis. Okay. So this is there are the change in temperature. When there's change in temperature, sometimes the heat is produced, sometimes the heat is absorbed. If the heat is produced, you say that the chemical reaction had taken place. That chemical reaction is called exothermic reaction. In some cases, heat is absorbed from the surrounding and used in the reaction. That is your endothermic reaction. Okay, these are the two chemical reactions when there's change in its temperature. Okay, let's move on to the next characteristic, that is your formation of precipitate. Okay, what is that? What do you mean by precipitate? That is insoluble substance. Okay, is your precipitate. We also call it as PPT. Okay, this is an insoluble substance which is formed during the chemical reaction. You take some two aqueous solutions, when you mix them, there's a formation of some precipitate that is insoluble in water, and it gets settled at the bottom of the beaker. You can see it, right? It is because it is not dissoluble. You cannot it is insoluble in water, so it settles at the bottom of the beaker. That is your insoluble substance, PPT. If there is any formation of PPT precipitate, means the chemical reaction had occurred. In this chapter, you have a example of lead nitrate. When it is reacting with potassium iodide, you're going to get lead iodide, which is yellow PPT formed. This is the example for formation of PPT. These are the characteristics of chemical reactions through which you can they give a visible evidence through which you can say that, oh, the chemical reaction had occurred. Okay, let's move on to the next concept. So what is a chemical equation? Is it same as chemical reaction? Let us see. A chemical equation is the symbolic representation of a chemical reaction using the symbols and formulae of the substance. So for example, now see, there's a burning of coal in the air is a chemical reaction in which a new substance, carbon dioxide, is formed. So they are saying some chemical reaction is happening in a very long descriptive way, right? If you want to say this in very short form, we use chemical equation. Okay, chemical equation is the shortest form of representation of a chemical reaction. Now we see a chemical change and we know that some chemical reaction might have occurred. We want to write it in a very shortest form, we use chemical equation. Okay, now the example says, when you make it into very short form, look at here, there's a carbon plus oxygen, you're going to get carbon dioxide. It is a very short and simple way of saying there is a chemical reaction happened and this is the reaction that has taken place. Carbon reacted with oxygen, you're going to get carbon dioxide. Even if you want it to in a simpler way, we use symbols. For carbon, we all know it is represented with C. Oxygen, we write it as O2 gas, and when they react, you're going to get carbon dioxide. CO2 is the formula for carbon dioxide. So now you have understood what is chemical equation. There are two types in which we can write chemical equation. So one is given here. So we are using words to represent equation, like carbon, here oxygen, you're going to get carbon dioxide. So that is why we call it as word equation. Okay, we call it as word equation. Here we are using, in this example, we are using the same carbon plus oxygen carbon dioxide equation. We are writing it with the help of a symbol. Carbon is represented in with the help of C. Oxygen, we write it as O2. Carbon dioxide is CO2. We call this as skeletal equation. Okay, there are two types. One is your word equation, where we are representing the equation with the help of the words, and if you are writing it with the help of a symbol, it is called as skeletal equation. And this skeletal equation is also unbalanced equation. We need to balance that. We'll see how to write a chemical equation now. Okay, or these are steps. Write symbols of the reactants on the left hand side with a plus sign between them. Write symbols of the products on the right hand side and put the sign of an arrow in between the reactant side and product side. Let us see. Now, for example, the A plus B is these are the reactants. Okay, you have to write the reactants in the left hand side, and in the right hand side the product. Think the Z is your product. Okay, or if at all there are more products, then you can add with plus sign and write Z plus Y. The reactants, if you have one more reactant, add C is your reactant. So if at all there is only one reactant, then A is converting into B. This is your reactant, this is your product. But if at all there are more reactants, then you divide them by adding this plus sign. Okay, the reactant is always written on the left hand side. Okay, you all know in mathematics what is left, LHS, which is left hand side, and the products are written on the right hand side. Okay, these are called your reactants. This is the products. Okay, and and between reactant and product we are going to put an arrow mark. What does this arrow mark indicates? This arrow mark is always pointing towards the product, and it also gives the direction through which the reaction is taking place. Now you know, when the arrow mark is starting from here and pointing towards this, you always realize that the reaction might have started from here, the direction, right? From starting from here and ending as product is here. So it shows the direction through which the reaction has taken place. It gives the information about that. When you write a chemical equation, you see left hand side, you understand that these are the reactants. Okay, on the right hand side, whatever has written, you understand that these are the products which are formed after reaction. And the arrow mark shows it always points towards the product, and it also gives information about the right direction of the reaction, means where it has started and where it has reached. Okay, so this is how you write a chemical equation for any chemical reaction. Now, there are a few important terms also that we use while writing a chemical equation. Like there's a S for solid, L for liquid, right? G for gas. To remember, we'll see with example. And there's AQ for aqueous solution. And there's a PPT for precipitate, and PPT can also be shown by downward arrow mark, and gas can also be shown with upward arrow mark. Okay, these are the few terms that we use while writing chemical equation. Let's see, for example, now I take an example of hydrogen, which is a gas. So I write it as gas, and oxygen is a gas, and H2O is formed, which is liquid in nature. So when you see any chemical equation, what are the informations that you get? Once you see on the left hand side, you see these are the reactants, and you understand that, oh, these are the reactants, and they are reacting. And what is the new substance formed? That is your product. You understand that this is the product, right? Product formed. And next you understand there are two reactants which are reacting to give you one product, right? And the arrow mark shows it is always pointing towards the product, and it shows the direction of the reaction happening. So direction, it started from hydrogen oxygen gas mixing, they are reacting to give you water, right? You have understood this. And the next information in the chemical equation is your state, right? The state of the reactants. Here the hydrogen is in gaseous form, oxygen is gaseous form. When they form water, which is liquid in form. So when you see a chemical reaction, you get all the informations that are you know like what are the reactants, what is the product, how many reactants are there, and what is the state of the reactants and products. All these informations are very you know represented in a very shortest form. So that is your chemical equation, right? Instead of writing it in a very descriptive long way, uh, the chemical equation helps us to represent them in the very shortest form with all the informations. When you look at any chemical equation, you'll understand what is the reactants, from where the reaction is starting and where it is ending, what is product formed, and what are the states of reactants and products, right? Whole information. So now we have understood how to write a chemical equation, right? Now let us understand why. Then the next concept is your balancing of a chemical equation. First of all, why to balance a chemical equation? First, before getting into how to balance and why to balance, we should know what is balancing, right? So now there is, you see an example, hydrogen oxygen reacting and you're getting H2O, right? You see two atoms. There are how many elements present? Hydrogen, oxygen, right? There are two elements present in both reactants and product side. Now you see in hydrogen element, how many atoms are there in the reactant side? Hydrogen is the element present. You have 1 and 2, two atoms of hydrogen present, okay, on the reactant side, okay. And oxygen, in oxygen element we have two atoms of oxygen present, right? Here two atoms of oxygen present. On the product side, again hydrogen is there, oxygen is there. Hydrogen, there are two atoms and oxygen is only one, right? Do you see any change? Here hydrogen present are two, here after reaction also hydrogen present are two. Here there's oxygen, two atoms are present and one oxygen here in the product side. Now we say the equation is unbalanced. It is an unbalanced equation, okay. Now you have understood what is balanced and unbalanced, okay. If at all the oxygen also present on the reactants and its product side are same, we would call it as balanced reaction. Now the number of oxygen atoms present on the reactant side is not equal to the oxygen present on the product side, hence it is an unbalanced equation, okay. Now we should ask the question, why should we balance? Why, ma'am? Now we have oxygen 2 here, and why can't we have 1 here? Why there is any need to have 2 atoms of oxygen here also? Why there is any need to balance, right? Yes, your question is absolutely right, and we'll see why there is any need to balance. Here is your answer. That is the law of conservation of mass. Mass can neither be created nor be destroyed. It can only be transformed from one form to another. You have all studied in your previous classes, I guess, the law of conservation of mass in 9th class. Mass can neither be created nor be destroyed. How many atoms of hydrogen or oxygen, present in the reactant side should be present in the product side? There should not be any loss of any atoms, because mass or matter can neither be created nor be destroyed. Only they undergo some rearrangement to give you some new product, right? The reactant side, you have two hydrogen atoms, two oxygen atoms. When they undergo some rearrangement, some chemical reaction happens, they undergo rearrangement. There is no new there is no loss of any atoms takes place, or there is no formation of any atom takes place. Only the present reactants will undergo some rearrangement to give you some new product, right? Hence the mass should be equal on both reactants and product side. So the total mass of the element present in the product of a chemical reaction should be equal to the total mass of element present in the reactant side, okay. Now we have seen hydrogen 2 atoms. Here in product side also there are hydrogen 2 atoms. In oxygen, in the reactant side we have 2 atoms, but in the product side we have only 1 oxygen. Now we have to balance that oxygen to balance, which respects the law of conservation of mass, okay. Why this part? Now you have understood Balancing means counting number of atoms of each element on the reactant side. They should be equal to the number of atoms present on the product side. Why there is a need to balance means the law of conservation of mass. It can never be created nor be destroyed. So the total number of the total mass of the element present on the reactant side should be equal to the mass of mass of elements present on the product side. To understand this law of conservation of mass better, take a beaker, take water, okay, in this, and add sugar, okay. Take water, say about 100 grams, and sugar some 10 grams, okay. When you dissolve that sugar in water, what do you see? The sugar solution is formed. And when you weigh that sugar solution, you should get 110 grams of sugar solution, because the mass can neither be created nor be destroyed. In the visible, what we see is sugar gets dissolved and we see that sugar is disappeared, but the mass can never be created nor be destroyed, means the mass is going to add up in the products when the sugar solution is formed, right? If you take 100 grams of water, and 10 grams of sugar, when you mix it, the sugar solution should weigh 110 grams. Okay, I hope it is clear. Let's go to the next concept, that is your balancing of a chemical equation. How do you balance now? Now we have come to know that how to see the balancing number of, counting the number of atoms on each element. Next, why to balance you have understood. Now we'll see how to balance. Okay, let us now see how to balance a chemical equation. Okay, now you have understood how to check for unbalanced reaction, and then you have to balance a chemical equation. So now first let's check whether the equation given is balanced or unbalanced, right? See how many elements are there? 1, 2, 3. Write it. Elements present. You have iron, hydrogen, and oxygen on the reactant side and on the product side. How many iron are there on the reactant side? You have only 1. Hydrogens 1, 2, you have 2. Oxygen only 1. Here there are 3 iron, 4 oxygen, hydrogen you have 2, right? You can clearly see here the number of iron are not balanced, here oxygen is not balanced. So this is an unbalanced reaction. So always the first step is check whether it's a balanced or unbalanced reaction. Now we have to balance, right? Okay, before understanding the balancing of a reaction, I'll explain 2 to 3 important things that you should keep in your mind while balancing. Okay, whenever you're balancing, never add any number in the subscript. What is subscript? Now you write H. This is 1 atom of H. When you write 2 here, this is the subscript place. It means there are 2 atoms of hydrogen here, right? But while balancing chemical equation, if you want to add any atoms which are unbalanced, you can never add number here. You can only add in the coefficient place. You have to add in the coefficient place, not subscript. Okay. Why? I'll tell you. Take for example H2O, right? You want to balance the number of oxygen. You want to add 2 oxygen. Imagine you want to add 2 oxygen atoms. Okay. If you add oxygen atoms here, it becomes what? H2O2, which is your hydrogen peroxide. Hydrogen peroxide is not water. It is a mild antiseptic that is used in the cleaning of wounds and cuts. You might have seen. So that hydrogen peroxide is not water. It is a different substance and it has different properties. So you can never add anything in the subscript. Okay, it's the whole nature changes. So when you want to add any number of atoms, you should only use coefficient place. You can add 2e here. Okay, now it becomes 2o. Okay, this is the question. People misunderstand that. See, now we have 2 here. It means 2 atoms of hydrogen. Okay, right. Yes, ma'am, we understood. Even if 2H is written like this, it is 2 atoms of hydrogen. Okay, that everybody understands. Now, if I write H2O, now there's one oxygen atom also. One atom of oxygen. If I add 2 H2O here, okay, now what happens? 2 atoms of hydrogen, 2 atoms here, right? Means there are 2 molecules of what? 2 molecules of water. 2H2O means. Now, how many hydrogens are there in one molecule? H2O and H2O is the 2 molecules of hydrogen. This is the 2 molecules of water formed. So there are 4 hydrogens. That's why 2 into 2 you have 4 hydrogens here. And 2 into 1, 2 oxygen here. Right? This is how you count. Okay. You should always write balancing numbers here in the coefficient places. Okay, never get confused. Don't add any number while balancing in the subscript place. Now you have understood how to count numbers. Okay, whenever if that all there is any 2 here, it means this 2 counts for both. It is related to both hydrogen and oxygen. Okay, this is how you. These are the important things that you should remember before balancing. Now let us see how to balance. First, as I told you, you should never add any number in the subscript place. So let us box them so that you'd never get confused. Box these present. So when you box this, the only numbers you can add to balance is here. Okay, you can never add any numbers within the box. Okay, so let's see how many elements are there. Iron, hydrogen and oxygen. Here the reactants and product side. Here there is 1 iron, here it is 3, hydrogen 2, here hydrogen 2, oxygen is only 1 and oxygen here is 4, right? To balance the iron, 1 to be converted into 3, right? How do you do? 1 multiplied by 3. When you multiply 3 here in the reactant side, now it is balanced. 1 3s are 3. Your 3 on the right reactant side, 3 on the product side. So write 3 here. Never write it within the box. You should write 3 here. Okay. And oxygen is also unbalanced. So oxygen 1 is here in the reactant side. To balance that, multiply with 4. Now it becomes 4, right? 4 on the reactant side, 4 on the product side. 1 4s are 4. So add 4 here. Okay. Now the iron and oxygen is balanced. But what do you see the change? When you add 4 here, there are already 2 hydrogen atoms. But when you add 4 here, now 4 2s becomes 8 hydrogen. So in the reactant side, whenever some elements are balanced, there is a chance that the unbalancing of other elements is natural. So when this becomes unbalanced again, so you have to again balance it, because it is an hit and trial method. We call this method as hit and trial method. Till every element gets balanced, you keep on doing the same thing. Now what happened? The number of hydrogens changed after changing the numbers of iron and oxygen. See, 4 2s are now, it becomes 8 hydrogen here. Now here hydrogens in the product side is only 2. Now you cannot do anything with the 8. We want 8, right? So multiply this product side as 4. 4 2s becomes your 8, right? In the when 2 is multiplied with 4, you get 8. So we are multiplying it on the product side, so we are going to add this 2 4s are. How much you are multiplying? You're multiplying 4. When you multiply 4 here, 4 2s are becomes your 8 hydrogen. So this is now a balanced chemical equation. Let us check whether it's balanced or not. Now see, 3 iron in the reactant side, you see 3 iron in the product side. 4 2s are 8 hydrogens. Here it is 4 2s are 8 hydrogens. And 4 oxygen, here there is a 4 oxygen. Now it is a balanced chemical equation. I hope this example is clear. This is an example of rusting of an iron, right? This is the balanced chemical equation. Let us see some other example to understand better and use another example. Zn plus H2SO4 will give you ZnSO4 plus H2 gas is released. This is an, metal reacting with acid will give you evolution of gas that I explained before. So check further. As I told you, whenever you see any reaction, they may trick you also. First of all, you should always check whether the equation is balanced or not. Don't go on board to put numbers. Okay, so let us see. What do you do? First write the elements present. You have Zn, you have hydrogen, and here you can collectively write it as SO4, or you can write sulfur and oxygen. Okay, their elements on the reactant side and on the product side. Now see, Zn is 1 here in product side also. It is 1. Hydrogens are 2. Here hydrogen 2 atoms. Here sulfur is only 1. Here sulfur is only 1. Here oxygen, you have 4 atoms of oxygen. Here also 4 atoms of oxygen. The equation is already balanced, right? There is no, the number of atoms of each element present on the reactant side is equal to the number of atom of each element present on the product side. So there's no need of balancing because it's already balanced equation. They may trick you like these questions in your exams also. When they give balance the chemical equation and you give this example, you should always write the equation is already balanced because the number of atoms of each element present on the reactant side is equal to the number of atoms of each element present on the product side. Okay, let's see one more example. Very easy examples. Okay, for example, take hydrogen plus oxygen, you're going to get H2O. Okay, elements, reactants and product. So you have hydrogen and oxygen, right? Hydrogen here is 2, oxygen in the reactant side is 2, product side hydrogen is 2, oxygen is only 1. So now you have to balance the oxygen atoms present. So in the reactant side you have to multiply with 2 so that oxygen becomes balanced. So multiply here. As I told you, first you have to always box. Okay, otherwise you get confused. So now what are you adding? Add 2 in the product side. Now it becomes 2H2O, right? It became 2H2O. As you balanced oxygen, the balance of hydrogen broke. Now see, there are 2 2s are 4 hydrogen atoms present on the product side now. You see, 4. Now you have to balance this 4 again. So to make the products reactant side 4, you have to multiply it with 2. To multiply here with 2. Now check, 2 2s are 4 hydrogens. Here 2 2s are 4 hydrogens. Here it is 2 oxygen. Here it is 2 oxygen. Okay, now the equation is balanced. Let's see one more example. So this is one more example. This we are going to study this equation, this reaction later in this video. First of all, always box before adding any number. Okay. Now check for the number of elements on the reactant side and product side. There's magnesium, there's oxygen. Magnesium on the reactant side is only 1, oxygen it is 2. On the reactant side it is magnesium is 1, oxygen is also 1. To make oxygen 2 here, we should multiply 2 in the product side. So when you multiply 2 here, now on the product side also magnesium changed, right? 2 magnesium. When this becomes 2, again multiplying 2 here, 1 2s are 2, it becomes an 2 Mg plus O2 will give you 2 MgO. Now there are 2 magnesium in the reactant side, 2 magnesium in the product side. There's 2 oxygen here and 2 oxygen in the product side. So now the equation is balanced. So this is how you balance a chemical equation. I hope any question you can solve easily now. So let's move on. So after balancing the chemical reaction, chemical equation, you have to remember if at all the any chemical reaction is taken carried out in certain conditions, like certain temperature should be maintained or certain atmospheric pressure is needed or any catalyst is used, we write on the arrow mark. Above or below the arrow mark we are going to mention it. Reaction A and plus B is taking place and you're getting a C product, but that reaction is only taking place at some 60 degrees Celsius for say, let's say. So you have to mention it over the arrow mark. Okay, so like that, any temperature, atmospheric pressure, if at all the condition is needed, then we are going to write it above or below the arrow mark. What do you mean by catalyst? Catalyst is the substance that changes the rate of reaction without being consumed. What does that mean? Rate of the reaction means speed of the reaction, right? In some reaction, the catalyst is used to increase the speed or to decrease the speed. Okay, when A plus B is reacting to give you some C, some Z is your catalyst. Imagine your Z is your catalyst. That Z is increase. We use that catalyst to increase the speed. Okay, so that reactivity, it is helping in increase the reactivity, but it is not consumed. Okay, it is retained. At the end of the reaction, you are going to get back the catalyst as it is. Nothing is consumed. It is not going to participate in the reaction. So that is your catalyst. So here there is an example of photosynthesis reaction. 6 CO2 plus 6 water molecules you are getting. Glucose plus oxygen is released, right? Photosynthesis. But it is going to take place only when there is a chlorophyll and sunlight. You all know this, right? Only green plants can in green plants photosynthesis occurs because in green plants there is a presence of chlorophyll. Chlorophyll is a primary catalyst in this reaction, where if there is a chlorophyll, it is helping sunlight to be absorbed. Okay, that is the reason photosynthesis is taking place only during the daytime and in the presence of only chlorophyll. Only photosynthesis takes place in green plants, not yellow, not brown color, right? So now let us understand some important reactions which are mentioned in your NCERT textbooks in activities. Okay, so the first reaction is magnesium ribbon is burnt in oxygen to get converted into magnesium oxide. Here is the reaction. So what is this? As I explained it before, magnesium plus oxygen, you are getting magnesium oxide. This is your word equation. We are using words. Magnesium plus oxygen gives you magnesium oxide. If you use symbols instead of words, it becomes your skeletal. Okay, where you are using 2 Mg plus O2 is giving you 2 MgO. It is a balanced equation, right? 2 magnesium, add 2 atoms of magnesium, 2 atoms of magnesium here in the reactant side. Same 2 atoms of oxygen in the reactant side. There's 2 atoms of oxygen in the product side. So the equation is balanced. So what is this equation? When we take magnesium ribbon, okay, magnesium is actually used, they make into sheets. Take that ribbon and when you burn it with oxygen, like in the air it is burning with oxygen, there's a formation of some white powder. That white powder is your magnesium oxide. Okay, the observations you see are whenever this reaction takes place, you can find some videos also present on the Google. You can go and see. You see that magnesium ribbon burns with a dazzling white flame. Very important observations. The questions are almost every time the questions are asked on these, that magnesium burns with a dazzling white flame. When the ribbon is burnt, you see a white bright light. So that is the reason you have to keep away from your eyes while performing this experiment. And the white powder is formed. As I told, that white powder is your magnesium oxide. You should remember, whenever you take magnesium ribbon and burn, you are going to get what? Magnesium oxide, because magnesium is reacting with oxygen in air. You're going to get magnesium oxide, which is white powder, and whenever it is burning with the dazzling white flame. Okay. Before taking, one note you have to remember in this reaction is, rub this magnesium ribbon with a sandpaper before burning with oxygen. Why? See, whenever there is taking a magnesium ribbon, there might be any layer of oxide, right? Some oxide layer is deposited. So to remove that oxide layer present on the magnesium, first we have to rub it with the sandpaper, and then you burn that magnesium ribbon, you get magnesium oxide, the white powder. And the while burning, it is burning with a dazzling white flame. The white powder formed is your magnesium oxide. So this is one reaction. We'll understand this reaction in detail while when we study the types of reactions. So these are the observations that you should keep in mind. And the next reaction is your lead nitrate and potassium iodide reaction. So lead nitrate and potassium iodide, when they react, you get lead iodide and potassium nitrate. This lead iodide is your LOPPT. Okay, this is the PPT which is formed. See, do you see in the picture? This is the yellow PPT, which is insoluble in water, and it settles at the, here it is going to settle at the bottom of that test tube. So what are the observations? Colorless solutions of lead nitrate. This is a colorless solution. Potassium potassium iodide is also colorless. When they are mixed together, you're going to get a bright yellow PPT, which is your lead iodide. Okay, and potassium nitrate remains dissolved in solution. So this is the reaction. Lead nitrate reacting with potassium iodide will give you lead iodide plus potassium nitrate, and this lead iodide is your LOPPT. Okay, let's move on to the next equation. Next reaction is your zinc sulfuric acid reaction. Okay, this zinc is a metal. When it is mixed with acid, you're going to get hydrogen gas released, right? So what do you see the observations? When green zinc granules gradually dissolve, bubbles of hydrogen gas are produced. Okay, that is the effervescence. The reaction mixture may become warm because the reaction is exothermic. I explained it before. When during some chemical reactions, if heat is produced, the reaction is called your exothermic reaction. In this reaction, the reaction mixture, it becomes warm because the reaction is your exothermic reaction here. And a colorless solution of zinc sulfate, this is a colorless solution, is formed, right? So this is the reaction. Zinc, when mixed with sulfuric acid, you're going to get zinc sulfate plus hydrogen gas is released. So all these are the mentioned important chemical reactions mentioned in your textbook. We will study these reactions in detail once we get into the types of chemical reactions. We'll deal that in the next part 2 video. Now for now, just remember the reaction and its observations, what all you see. Okay, these are the practice questions. Please try to take a screenshot and try to balance these chemical equations. So that's it for today's video. This is part 1 of chemical reactions and equations, and the remaining topics we are going to cover in the part 2. The video will come very soon. If you really liked the video or understood any concept, please comment down, share this video, like this video, and please follow Kulkarni classes for more such videos. Keep supporting. God bless you all. Until the next time. See you. Bye-bye.